Hello students, today we will see construction and working of quantum dot laser. So what is a quantum dot? We have seen all the quantum structures in the previous videos, that is starting from bulk state up to quantum dot. You have actually 4 states. Bulk can be excluded, remaining 3 are actually quantum structures, that is quantum well, quantum wire and quantum dot. You know, quantum well is confined in one direction. Quantum wire is confined in two direction. Quantum dot is actually confined in all the 3 directions. So what is a quantum dot? This quantum dot basically is a semiconducting nanocrystals whose crystal dimension will be around 2 to 10 nanometers. Now these quantum dots can be fabricated using molecular beam epitaxy or metal organic vapor phase epitaxy, etc. on a substrate. Now let us see another picture for understanding this quantum dots. Now you can see in this first picture showing electrons moving randomly in all the directions. Now when the electrons reaches the Bohr radius, these will be trapped to form quantum dots, which is shown in the second picture. These quantum dots can be of any shape, like it can be spherical, it can be square, or it can be a pyramid shape also. In the third picture you can see the quantum dots arrangement from a upper view. Now these quantum dots are mainly useful for producing color in any display devices. Now the size of the quantum dot is very important for producing different colors. How well we are manipulating the size of the quantum dot, that many colors can be possible. Now for example, if I am taking a quantum dot of size say between 5 to 6 nanometer, it emits orange or red color. Now suppose I take a quantum dot which is having a dimension of 2 to 3 nanometer, that is a smaller dimension. Then it emits out blue or green color. So the size of the quantum dot decides the color. So how much you are able to manipulate the size, that many colors are possible. So today in all the display devices, in TV monitors, we are able to see a crystal clear color. It is all because of the quantum dots. Let us learn some basic information about quantum dots. For a quantum dot, quantum confinement occurs when one or more of the dimension of a nanocrystal approaches exciton Bohr radius. Electron energy levels can no longer be treated as continuous, they must be treated as discrete. This you would have seen in the previous video also. The energy levels of a quantum dot can be adjusted according to the needs of the application. For instance, the addition or subtraction of just a few atoms to the quantum dot has the effect of altering the boundaries of the band gap. Changing the geometry of the surface of the quantum dot also changes the band gap energy, owing again to the small size of the dot and effects of the confinement. Now we'll see the construction and working of quantum dot laser. Now you can observe in the picture and understand that quantum dot laser is actually a layered structure. And in this you can find out quantum dot in the middle. Normally quantum dots are made up of INGAAS, that is IN and GA taken 50% each along with AS. Then above and below you can see ALGAAS, that is AL 0.85 GA 0.15 along with arsenide. Then you can see at the bottom NGAAS, which is going to act as a substrate. You are having a p-doped GAAS is also present at the top. Then a metal cap is there from which the metal contacts can be given. Now this is the overall structure of the laser. Now the laser emission is actually going to take place in the from the layer where the quantum dots are there. Now what is happening means the 2 micrometer thickness material are shown above and below the quantum dots. These two materials are chosen in such a way that their band gap is comparatively high, so that the laser comes out only through the quantum dots. And also, because we choose the band gap to be higher for these two materials, the confinement for the quantum dots becomes easy. Anyway, we have to keep in mind that quantum dots homogeneity is a big task which we have to keep in mind. So if we are successful in maintaining the size of the quantum dots uniformly, then the output will be better. Now at this point you can raise a question, what is so special about quantum dot laser? Why should I come from a semiconductor laser? This is also basically a semiconductor laser only. Then why should I come from a conventional semiconductor laser to this quantum dot laser? Now the answer is very interesting. If you take a conventional semiconductor laser, you can only produce a particular value of a wavelength. So how you are taking the material, accordingly you can get one wavelength. But in quantum dot laser, it is not so. You will get a range of wavelength, which means you can tune the instrument so that it produces a range of wavelength, which is going to be very useful for many display devices. Today we are moving on to fiber optic communication. That is possible only because of this property and this quantum dot laser. And as I told you already, these quantum dots are useful for producing color on the display device. So how much you are able to manipulate, that many color shades are going to appear. Today the clarity what we are enjoying is mainly because of quantum dot laser. Apart from that, this is very useful for communication, optic, that is fiber optic communication. Okay, coming back to the construction and working of this quantum dot laser. Like a conventional semiconductor laser, here also it requires two conditions to be satisfied. One is population inversion, the other one is stimulated emission should be made dominant. And this requirement is not going to be a big requirement here, which means the population inversion need not be so high like it was expected in the conventional semiconductor laser. Some population inversion is required, which can be simply done with the help of injection itself. So population inversion will be achieved and lasing action will take place. So the laser will come through the layer where quantum dots are there. So you can see that in the picture. Same like semiconductor laser, you are going to give even here the same forward bias only. Now the length shown at the top, LC and W, length and width, these two parameters play a big role in the output wavelength. So they have to be measured and they can be manipulated also. According to our application, we can manipulate this length and width. So this is the construction and working of laser, quantum dot laser. I'll show you two more pictures for better understanding. You see the first picture. The quantum dots are responsible for producing laser. Now that region, that layer is going to act as an active region. You know, in a conventional laser, we always will mark which is the active region and which is the active center. So here the layer where the quantum dots are available is called active region, and the quantum dots are called active centers. So that has to be noted. Now the layers above and below are going to be chosen with a higher band gap, so that a quantum well is created, into which only we are introducing quantum dots. So this point has to be understood. Now the layers above and below are going to act like a cladding, and the quantum dots layer is going to act as a core. So you should be remembering core cladding arrangement is a optical fiber. So this acts like an optical fiber and the laser emits through the core, that is quantum dots. So this has to be understood. Now the one more requirement is there. In a conventional laser, you should be remembering the photons which are emitted are allowed to move between the walls of the two mirrors. Then after sufficient amplification, it will come out as laser. Here also you are going to do the same thing. How means you are having that layer which is having quantum dots, no? So these two walls are going to be coated with a special high reflectivity material. So you can take an example as a zinc selenide. So that is going to be useful for coating, so that the dots will move between the walls till it is properly amplified, and it will come out as laser through that layer. So this is about the first picture. Now in the second picture, you can see how the commercially available quantum dot laser will appear like, and also a magnified picture of quantum dots is shown. Now we'll go for understanding the output. Now before we go for this, few more things to know. That is, before we came for this quantum dot laser, what was the previous version of laser we were using? The answer is quantum well laser. Now if suppose you ask why we have moved on to quantum dot laser, means the gain. Gain is actually proportional to the confinement. So how well you confine, that much of gain is possible. So better than the quantum well, quantum dot is having a higher confinement. So that is the advantage of quantum dot laser. One more advantage is, when compared to conventional semiconductor laser, here this is less temperature dependent, which you can even tell it is temperature independent also. So it is not very sensitive to temperature. You can use even in the higher range of temperature. You cannot completely tell it is independent of temperature, but definitely it is much better compared to a conventional semiconductor laser. In a practical quantum dot laser structure, the injected carriers can thermally escape from the lowest state, that is ground state, into excited state, wetting layer, or even jump out of the heterostructure. As a result, the recombination processes of the carriers give rise to an additional component of threshold current, which depends exponentially on temperature. Now you can see in the picture, that is in the right hand side picture, the graph is drawn between current and light output. So you can see the threshold current being shown. So for this system, you are having the threshold current as 4.1 milliampere. Now you can see the light output is not simply one point. It is a distribution curve. It is a range, which means it will correspond to a range of wavelength. So what range of wavelength means? You can see inside a picture is drawn. So it is in the range of infrared. Now if you adjust a particular value of current, then you can get a particular value of wavelength. So you can get a range of wavelength with one device. All that you have to do is you have to find out the threshold current. So this is about the picture shown on the right hand side. Now come to the picture shown on the left hand side. This is a curve drawn between threshold current density and temperature. Now this is actually, you can change the width and length cavity of the quantum dot laser. We have seen in the picture, no, L, C and W. By varying, you are getting an exponential curve. Now this factor is dependent on temperature factor. This has to be understood. So very conveniently, according to temperature and according to the expected wavelength, you can tune this quantum dot laser. So the output will come according to your need. So that is the biggest advantage of quantum dot laser. Now we'll see few advantages. Broad spectrum with a specific wavelength of light emission can be obtained by changing dot size. Because of very small active volume, only very less population inversion is necessary for lasing. It is less temperature dependent. It operates at high frequency. Gain is 2 to 3 times larger than the quantum well. It is an efficient laser. There are few disadvantages also. It is very difficult to form high quality quantum dots. And of course, it is not cost effective. Coming to applications, few to tell, used in fiber optic communication, used in TV display screen. It's mainly used by Samsung, LG and all. It is used in medicine. So with that, I'll stop for today. Thank you.